Okay, this is my presentation for the inquiry training model. And I originally developed this as a handout because I didn't read appropriately, that we would be giving a presentation and uploading it to YouTube. So I adapted my handout to a presentation instead of the backwards version. So I didn't follow the cardinal rule of presentations where you have less text and on the screen. But luckily, since you can access that, you can read that for yourself. So my first thoughts when I was trying to think about how I'd present this, how I would teach this type of teaching model, was to adapt each of the phases identified by Joyce Weil and Calhoun to how teachers would do it, think of it, and how students would think of it. And it's not terribly different, but it helped me get into the mind of what students would be thinking. So essentially, you present the puzzling situation. Students immediately start going into a question and answer situation. Okay, there's phase two. And the answers to their previous questions help them go on to, hey, what can you deduce from what the teacher's telling you? And these questions are yes or no, purely. Students then proceed to experiment, seeing what happens if they change something, seeing what if they can directly test, does this confirm what we think we know? From that experimentation, they go into explaining things. And we want them to explain all properties of a situation. So that's something where a teacher has to be formatively assessing and constantly guiding students. Finally, the fifth phase is the metacognitive phase, which is probably the most important. How can you reflect on your learning? How can you improve your ability to learn and to move through this process? So in the first slide, it said, listen to the situation and learn the rules. Here are the rules that we would present to students. So you can read these clearly, but it's more the rationale behind those rules that I want to talk about. So questions that must be answerable with a yes or no, we want to shift as much thinking to the students as possible. And that's actually happens throughout here. The freedom to ask, this is inquiry. Of course they have to ask, they have to be able to ask questions. We have to really consider our responses to each of these questions. We have to either think of, hey, can you rephrase that into a way that I can actually answer that? It's ultimately wanting to make sure that a student is deducing as much as they can. One thing that I didn't stress as much as I should have in my previous explanation is that students should move fluidly between steps 2, 3, and 4. They should constantly be asking, experimenting, and trying to explain. This science is a messy process, and that's what the inquiry model is ultimately adapted from, is the method of scientific inquiry. And so it's not a nice, neat lab report all the time. I think this works best in cooperation. That's what all the research that I've done on inquiry and inquiry-based learning has said. So this blends really, really well with group investigation, I think. And obviously the sixth rule, the teacher should provide enough materials that students actually can experiment, whether that's reference books, whether that's actually being able to physically do something, or internet applets or whatever. I found this neat table that was in a science textbook, actually. And it shows the different varying levels of how inquiry can work. And I mean, you can read for yourself, but there's more learner self-direction and less teacher here on the left, and there's more teacher and less student direction over on the right. So this model is not just, it has to be done this way. Obviously, there are degrees of separation, and you know your students the best and how they will best learn and how you'll adapt it. Basing this model is a statement on truth. So the idea is that knowledge is tentative, emergent, and negotiated from the authors in this model, and that fits with radical and social constructivism from Glassersfeld and Yackel and Cobb. And it's just the idea that learning doesn't happen in a vacuum. And while students have to relate knowledge to what they know, it also emerges over time with discussing things with peers and with experts. There's the social aspect. Richard Suchman did the originating research on this model. His basic idea was this is how kids learn naturally, so why don't we harness that and try to make them cognizant of it so they can get better at it. Various teaching and learning theories that I've been exposed to that immediately relate to this model is Bruner with discovery learning. And these are all pretty much math-based research. So I'm sure there's other research, but this is what I know. This fits with Montessori's philosophy of playing to learn, because we're harnessing what students are doing naturally. They're curious, and we're trying to make that into something that's productive in our eyes. The social aspect comes in here with the third point. When you're cooperatively learning and performing inquiry, you're using a community of practice. And again, that's just the idea that learning happens through social interaction. It's not in a vacuum. It's not just mimicking what you see the teacher do. Bauersfeld has a ton of applications here, and he's a social constructivist. So I mentioned this earlier a little bit, how learning happens as a way of speaking between peers and experts, and that's where the meaning theory of learning comes in. And this emphasis of inquiry and trying to become better at it is a focus of process over product. So the process of inquiry is more important than the individual things that kids are learning, because we're teaching them how to learn by themselves. And ultimately, that's way more important than specific objectives, because it helps them become lifelong learners. So specifically in my classroom, kids work in cooperative learning groups, and they work through guided investigations from CPMP, the Core Plus Mathematics project. We go through guided inquiry, and we have inquiry into mathematics and inquiry with mathematics. So there's a difference. Inquiry into mathematics is exploring the different processes and figuring out how math works. What are all the processes? It's looking through procedural fluency for anyone who has read some of the NCTM materials. However, inquiry with mathematics is looking through problems and trying to figure out what problem-solving tools we can use to do those. So these investigations are centered around a problem, and it's a contextual problem. And through that, the book guides students through how procedures eventually come through. So it blends the inquiry with and inquiry into mathematics approaches. Now, the rationale behind this is this sub bullet that Simon has. It's a much more constrained model of inquiry than what Suchman would prefer, but in a content-driven classroom, which is a secondary classroom, absolutely, we have to narrow the focus, and we have to make sure that the ideas historically that have been developed are covered, because we have to prepare students for what's coming. We have classroom resources as needed, and whether that's notes or graphic calculators, instead of yes/no questions, I guide students with Socratic questions. So I answer a question with a question to help guide students. And I've linked on here, notice the different phases of what the authors identified as how this model works. I attached one of these investigations, and you can look through theirs. One important one is Summarize the Mathematics, and it's reflection on their inquiry. This is not necessarily a reflection on processes of learning, because we're guiding how they're learning with the blended model of inquiry with an inquiry into mathematics. So instead, we want them to reflect on what they've learned to try and put that conceptual model, that schema, into their heads. Here's all of my many references that have been put throughout. And I'm going to open up my activity so I can kind of show you what these look like. So this is one of the first ones we do on the year, and it's an investigation into power models. So with regards to phase one, we're looking at, hey, this is what's important. This is the phenomena that we're looking into. And these are kind of essential questions. And specifically, we look at sound and light intensity. So that's the phenomena being explored. It works really well. I've noticed the key is that students tend to not actually read the instruction they're given, and those are the main hard points. So phases 2, 3, and 4, asking questions, experimenting, and confirming hypotheses, all happen in conjunction throughout this guided investigation. Here's the Summarize the Mathematics that I was referring to. And after kids go through that, we discuss as a class, and I put together the toolkit entry or summative model, or the summative piece at the end. So as I mentioned on my handout, it's reverse guided release. And that's basically all I have for the inquiry teaching model.